Okay, some statistics. So the highest for midterm is 48, and the lowest is 18, and the average and the median are both 31. Why?
Average, same as median.
Oh, okay. So we covered many things in midterm, from crypto basics and from data link layer to application layer. So today we are going to go through all those questions. The first, we will talk about crypto first. Question 4, how many keys are required for two parties to communicate securely using symmetric key crypto? Because we are using symmetric key, so both parties have to share the same key. So the answer is just the one key. And how many keys are required for n people to communicate with each other? So in this case, each pair of two parties, they have to share one key. So, which means if there are 4 people, there should be 6 keys. So it's a number of edges between each pair. So the answer is D in this case. So many people get this one right, but not this one. And question 5. Actually, we asked this question several times in quiz and also homework, but still, every time I ask this question, I change a little bit, but basically it's the same thing. So when you want to generate a signature, you have to use your own private key. So everyone else can use your public key to verify your signature, but only you can generate the signature because it's your private key. So the CA will use its own private key to sign the website's identity and the website's public key. So in this case, the CA create a binding between the website identity and the website public key. So everyone else can verify that this public key actually belongs to this website. I think you did good in this question. And the hardest question in this exam is question 12. So we discussed a little bit in class, but didn't really get into this question. So basically what it's asking is in CBC mode, if there is an error in transmission, like C1, and obviously, let's say this is C1, and the answer to this question is no. And let's say this is C1, and C1 is somehow corrupted in transmission. So C1 is used to generate P1. First, the C1 is decrypted, the XOR with IV. So P1 will also be, the plaintext one will also be corrupted. And also C1 is used to XOR with P2. So P2 is also corrupted. But this will not propagate to P3. Because P3 will only use C2. So imagine C2 will be here and C3 will be decrypted. So P3 will not be affected by this error in transmission. So the answer to this question is no. So I think only 5% got this one right. Okay.
So if C1 was corrupted in encryption, the entire thing?
So in here, we only say the corruption happens in transmission. Yes. So if C1 is somehow corrupted here, something goes wrong in the encryption algorithms, that does propagate. Yes. So the next question, question 13, maybe less than half got this one right. So we talked about 3 days in the class, and the 3 days is basically running days 3 times. But in the middle, we're not using encryption, we're using decryption. So the question is whether using decryption instead of encryption makes the crypto stronger. So actually, no. So encryption, decryption, in this case, they have the same strengths. So the reason we are using decryption instead of encryption is we can provide some backward compatible with the previous steps. So if we're using decryption in the middle and we choose 3 keys, identical 3 keys, then 3 DES will be the same as the original DES. But it will not make this encryption, decryption, encryption stronger than 3 encryptions. Any question here? No? Okay. Then we have many network questions. Question 1, how many layers in the OSI reference model? And 90%, 95% got this right, but still some people choose 8. Yeah. So actually there are 7 layers in the reference model, and there are several other models we usually use with 4 layers or 5 layers. So whenever you read something talking about how many layers, you need to pay attention in any blogs or newspapers. The next question, which layer is responsible for delivery of a message from process to process? So the correct answer is transport. So at the transport layer, there is a port number, and that port number is associated with process in operating system. So the operating system will assign port number to different process. Yeah.
Did you skip 2 for a reason?
You did first.
Oh, you did? Oh, I must have missed that.
So I'm reordering this actually based on the layers.
Oh.
And which layer is responsible for the delivery of a message from host to host? And that is network layer. Basically, the IP protocol is delivering a message from host to host. Then the operating system in the host will decide which process it will deliver this to. That is a transport layer. And the data link layer, usually they are only responsible for delivering in a local network. And the application layer, it's not really tied with this kind of delivery. They have their own logic. They use the service provided by the transport layer. The next question, IP headers includes all of the following except the correct answer is C, port number, because port number is in the TCP or UDP header. It's part of the transport layer, not the network layer. So IP headers, it does have this destination address, which is an IP address, and because the IP message could be very long, so it's possible that we need to fragment it. So when we fragment the IP packets, we need to identify the fragmented IP packets. They actually belongs to the same original IP packet. That's why we have a identification number there. So this number can identify different IP packets. They actually were splitted from one IP packet. Then they have offset used by the receiving side to assemble that. That's why we have a fragmentation information. So the correct answer is C. Next one, the bytes of data being transferred in each collection are numbered by TCP. So the numbering start with a random generated number. So not 0, not 1. So in Wireshark will help you to read those numbers. So Wireshark will show some relative numbers. So it always start with 0, right? Doesn't matter 0 or 1 actually. So why do we need randomly generated number? Because for security reasons, random is just for security reasons. So we talked about that in TCP attacks, and we have another question in TCP attacks later. Question 6, which protocol is a process-to-process protocol that adds only port address checksum and length information. So because it's process to process, so you can only choose between TCP and UDP. But the TCP, it also has other sequence numbers, acknowledgement numbers. So the correct answer here is B. UDP is a protocol. Okay, the next one. Both TCP and TLS use which algorithm to encrypt the data transmitted? So this is also a trick question. It almost has nothing to do with IPSec or TLS. So whenever you want to encrypt something large and transmit that, you should use symmetric key crypto. Maybe before the asymmetric key crypto get faster. What? There's typo?
Yeah. I think it's supposed to be fast. Symmetric should say.
Oh yeah, sorry. Oh okay. Oh, I copied it twice. Okay, so basically, asymmetric key crypto has a lot of advantages. The best is we don't have to exchange the key because they have public key and private key, but it's relatively slow. If you remember, the symmetric key crypto is just very like the classical crypto we studied before. So just transposition and the substitution, so they are fast. But the asymmetric key are based on some mathematical foundations. They are relatively slow. So usually we only use asymmetric key to encrypt some short message, such as key, and use that shared key to do symmetric key crypto. Yeah.
So HTTPS is like HTTP based, like built on TLS, right?
Yes.
But doesn't that use like signatures and stuff? Isn't that public private key?
But that part is used for authentication, integrity check, not for encryption. And message authentication code basically is keyed hash. Hash is used for integrity check. And message authentication code is for integrity and authenticity. So the next question, what is the difference between IPSec transport mode and turtle mode? Which part of a packet is protected? And what is the major security service provided by AH and ESP? So we studied this before. Turtle mode usually used for gateway to gateway. And this is the original IP packets. We have IP headers. We have transport layer headers and data. And in transport mode, we want to protect this transport layer data. So we will add a new IPSec header between the original IP header and the TCP header. Then this part can be encrypted and authenticated. And also the IP header can only be authenticated but not encrypted. Because if you encrypt this part, there is no way the routers can figure out how to route them. But in turtle mode, the whole packet is protected. So this part is treated as a payload, and this can be encrypted and authenticated. Then we need a new IPsec header and also a new IP header, so the routers knows how to route them. So if you answer, so basically for the transport mode, you need to answer only the transport payload is protected, and also the IP header is authenticated, and in the turtle mode is the whole packet is protected. So for the IPsec header, we can use authentication header and encapsulation security payload as well. So basically, AH is used for authenticity and integrity, and ESP is for encryption. The next question, question 2. Which protocol can protect a local network from up spoofing attack? And which protocol can authenticate and encrypt each IP packet, including IP headers and payload. So the second question we just discussed. So IPSec can do that. So TLS cannot authenticate and encrypt IP headers and IP payload because TLS only cares about the transport layer. It will leave the IP headers alone. Same thing as HTTPS because basically it is just TLS. And IPSec doesn't protect data link header as well. But in order to protect a local network from up spoofing, basically we want to authenticate the physical address. So we need some protocol to authenticate the physical address. And IPSec cannot do that. TLS cannot do that. So the answer is D. So in the class, we discussed the one protocol that was be able to do that, but it was not widely used in reality. So this one is DA. I think a lot of people got this one wrong, and also this one. Yeah. Okay, question 9. So now we are in the application layer. So which of the following is a subdomain of example.com? So what is subdomain? So one domain is a subdomain of another if its domain name ends in other's domain name. So safecom.asu.edu is a subdomain of asu.edu and also .edu and maybe also .dot. So and asu.edu is a subdomain of .edu. So the answer is A. Games.examples.com is a subdomain of example.com. So this question is a little bit tricky as well because D, a lot of people choose D, but actually those two domains, they do not have direct relationship. So they look like they are related, but not really. So .com is a top level domain name, and .us is also a top level domain name. And so example.com is a subdomain of .com, and example.com.us is a subdomain of .us or .com.us. They're not really related. Question 16. Explain the difference between recursive and iterative name queries. So a lot of weird answers for this one. So recursive query basically is a resolver must complete the recursion, and the response must be either an IP address or an error. But iterative, let's say, iterative means the response must be an IP address, an error, or the location of an authoritative name server. So here is an example. So this is your computer. Your computer will set one server as your DNS server. And your computer usually will send out a recursive query to your DNS server. And your DNS server is going to resolve that for you by asking all other servers. So the DNS server will first query the root server, and the root server will not return the IP address of 3w.example.com. Instead, it will refer it to another top-level domain server. So your DNS server is doing this recursively for you, so it can return you an IP address, or I cannot resolve that. But all those servers, the root servers, is not going to query all other servers for your DNS server. It will just refer to your DNS server, please query the other one. It will not doing that for you. So your DNS server is a recursive server, and the message you from your computer to your DNS server is a recursive query, and all the queries in between, they are iterative. So how do you know if a server can support a recursive query? Usually in the DNS protocol, a server will tell, when you do a query, the server will tell that if I support a recursive, can I do that recursively for you? So this is it. And the last question, how can an attacker, host E, reset and establish the TCP collection between two hosts, and how it can inject some malicious data to establish the TCP collection? So basically, what I'm asking is, what? Okay. So first, the host B and host A already has an established TCP collection. I guess you guys are familiar with this one now because you did an Lab3, right? But we had the exam before Lab3. So basically, host C has to get a valid sequence number, valid acknowledgement number, and source IP of host B. So if you are experiencing some problem in the last task of Lab3, probably you didn't get the sequence number right. Probably. And you also the host can set the fin control field or reset. And the hijacking attack is very similar actually, but you don't need to set fin or reset. So basically, you still need to do IP spoofing. You still need to get the valid sequence and the acknowledgement number. So that's the 3 points I'm looking. Spoofed IP, valid sequence, and valid ACK number. So if you got that right, you should get the full score. Then question 15. The IPv4 header has a field called TTL. And the DNS resource record also has a TTL field. Are they the same thing? So I don't really care if you answer they are the same thing or they are not the same thing, because based on your own understanding, I'm looking for the answer, what they are actually used for. So for the IP header TTL, basically it is used to ensure that a packet is eventually dropped. The reason that is in our network, there could be a lot of loops. So this is very understandable because each router is configured by different administrators. So before SDN, there is no really a global way to configure all the routers. So it's very possible that everyone is doing their job correctly, but if we say everything in a big picture, there is a loop, there is a lot of problems in the network. So to ensure that any package is eventually dropped, we have this TTL field in this IP header. So whenever an IP packet goes through a router, that TTL field will be decremented by 1. So if that value drops to 0, and the router is supposed to drop that packet. But the TTL for the DNS records is used to specify how long the cache is valid. So usually that's a time in seconds, and here this is a number of hops. So if that time drops to 0, which means your DNS server should get rid of that record, should update that record. The last question, question 10. So DNSSEC guarantees all of the following except the first one is authenticity of DNS answer origin. The second one is integrity of reply. C, authenticity of deny of existence and confidentiality of DNS query. So basically the security challenges our DNS system is facing is there might be some fake DNS servers, and there might be some fake DNS record. But the DNS record is not really a secret, so there is no need to make it a secret to maintain the confidentiality. But we need to verify that the DNS answer is actually generated by a legit DNS server. So A, B, C, all the functions of DNSSEC, but not D. So very, very interesting is all the systems, including DNS systems, they are also facing denial of service attacks. And so last Friday, when we were having the IA symposium, and I think this month is the National Cybersecurity Awareness Month. So last Friday, when we were having the meeting, so there was a organized unprecedented attack to DNS servers. So basically, those DNS servers, they got a DDoS attack. Yeah.
I heard that they use a lot of unsecured Internet of Things devices.
Yes, that's what also what I read from news. So what they said is because a lot of IoT devices like a webcam, they have a weak password, hard-coded password in their firmware. So they were taken control by a large botnet, and so that's why a lot of IoT devices were used to just make queries to the DNS servers of a particular company, and that company is huge. So it said that maybe 10 millions of IP address was used in a very short time to do that attack. So I have a question for you guys. We started DNS. It is supposed to protect our DNS system, the DNSSEC. So can DNSSEC protect us from this kind of attack? So the incident happened in Friday. Is it because we haven't deployed DNSSEC, or is DNSSEC cannot even protect this? Anyone say yes? Yes. So not really. So right now we don't really have a way to protect this kind of DDoS attack, and DNSSEC is just there to provide authenticity and integrity of DNS. So this is very interesting that if you remember our DNS infrastructure like this one, so the root servers were intact in this attack. So some of the DNS servers in the middle, which is, what is the company name? Dion DNS? So that company's servers, they're not the root servers. They're in the middle in this hierarchy. They were under attack. But when your browser tries to resolve that domain name, it goes to root server. That's fine. The root server send a message back to your DNS server. Then your DNS server tries to talk to that dying company's DNS server, and that part didn't work. So technically, if you know the IP address of Twitter, if you know the IP address of Facebook, probably you can still access those websites, because some website is behind those reverse proxies, so they do not allow you to directly access your IP. But still, many companies you can directly access those web service through IP.
So this would be similar to the lab exercise, the SYN flood. They used, somewhat similar type of attack, but a distributed version of it.
Yes.
Where, so
That's true.
name server couldn't field the reply, just like your telnet session, you couldn't connect the telnet session.
So in the lab, we are directly attacking the targets. But here, those criminals, they are not directly attacking the targets, but attacking the DNS servers. So the Twitter, Facebook, they were actually not under attack. Okay, so last Friday, we had the IA symposium. I saw maybe 10 faces there, and there was a very good session. The last session, a tech lead from Charles Schwab, he demonstrated several kinds of attacks and how his team in Charles Schwab can respond to those kind of attacks. And I was happy to say that what he demonstrated there was very close to what we are teaching in this class. So you can see that the gap between what we teach in the class and between what is actually used in real world is not really that big. So I will try to invite that guy to come to our class and do that demo again to all of you. But I haven't, I don't know when, maybe the last class of semester or the last week. Okay, so if you have any questions, please let me know. That's all for the midterm. Oh, yes. Hello.
And so I think a lot of us are having trouble in the lab.
Okay.
So after you do like the
So which one? The task?
the task 3, after you do all the commands, how do you send the PWD command? How would you do that? I couldn't find anything online that helped me really.
I will email everyone later today.
Okay.
H-O. Last name H-O? So this is not correct, that's a problem. Maybe you guys can check also. Yeah.
So this is 5 points total, and I was getting 4 points. I was looking at it.
Okay, this part is correct. Oh, the reason is you didn't explain that if this will increase the strength of 3 days.
Oh, okay. Thank you.
I have a question about the web. For the first task, when you do the S and Y floating, should it be affecting the whole VM, correct? Or should it only be affecting accessing websites?
Depends. Depends actually. I think it will affect the whole VM, but that's not what I asked you guys to show. So basically, as long as you show that there are a lot of half-opened collections, that will be fine.
Okay, because when I was running it and I was looking at it through Wireshark, I was getting a bunch of requests.
Yeah.
So I took a
And also
screenshot of
replies.
Yeah. So, but like as I was going through, I was like having harder.
Okay.
I was having harder times like accessing the VM because it was like slow down the whole thing.
That's why it's called a denial of service.
Yeah. I just wanted to make sure it was supposed to be affecting the whole VM and not just accessing.
Depends on the resources you assign to that VM. A lot of things. Yeah.
So
Alright, thank you.
was corrupt. It ruined this one and this one, but since this one wasn't, it did not ruin that one.
I check on my grade and I got
Something wrong?
0.
I see over there.
So I
Oh, really?
I think the TA.
Do you have that?
I'm asking him because
Okay, setting up this is easy. I can help you.
that's not the problem. It's
Let me check.
Your computer sucks.
I have 4 cores though.
Too bad.
That's what I was gonna ask him.
Mhm.
I'm having issues downloading
I downloaded mine. I can copy it
do you have
to
any
USB.
Downloading what? The VM?
the zip. No, the zip. So I'm having
It's too slow? That's what you're saying?
yeah. So do you have a suggestion? Because every time I try to download it, no matter which Explorer I use, one doesn't work, one doesn't. It's having issues.
I don't have
I have a USB.
The USB?
Yeah.
Okay.
that'll be perfect.
Yeah.
Thank you. Thank you.
That's
Yeah.
So the solution is going to be on Blackboard
Which solution?
for the exam.
Oh, what happened?
Yes.
right when you said that, I clicked it. Oh, shush, you're fine.
This is the